All right, so last night, actually I gave it to you on Monday. There's really no reason why we couldn't do 13 minutes of video notes and upload what you did. It literally took less than 15 minutes. I don't know why, but anyway, so here we go. Basically you had a matter concept map. So most of you already have this written down. If you don't, you can write down what I have, but it's not going to be as detailed and accurate as the video notes because you should already have it written down. So we had a matter concept map. This was kind of the whole header, and then we were breaking out how that breaks out into different things. So you kind of had some stuff that broke out this way, some stuff that broke out this way, and then we broke it out again, okay? So it talked about how you could physically or chemically separate it. And then what you ended up with at the very bottom of the concept map, so you had some stuff in here, okay? But then at the bottom, you basically ended up with solution, colloid, and suspension on this side. All right, so most of you should already have this down. And then on this side, you ended up with an element or elements and compounds. All right, so we're just going to talk a little bit more about each of these. So the video notes kind of gave you a good overview. All right. So let's start with elements, okay? Where can you find elements? I gave you something in the thing. You could find elements. Where is it?
The periodic table.
Very nice. Periodic table. All right, so usually this is where my Zoom freezes because I try to share screen from here. So I'm going to try to share from this screen. Let's see. Share screen. All right, so here's my favorite site for the periodic table. It is called ptable.com. Okay, it's called ptable.com. And so it's right here. Oops. ptable.com. Super easy. That's all you have to type in. And it gives you all the elements on the periodic table. So an element cannot be broken down any more than what it is. You can look at the atoms of it. You can look at the protons, neutrons, and electrons. But if I have, for example, if I have copper, that's what copper is. Like, I can't break down copper into anything else, okay? It is going to always be copper. It may be the atoms of copper, but it is still copper. I cannot physically break it down and make anything else, and I cannot chemically break it down and make anything else. So that's what makes an element an element. So these are the things that are occurring. I won't say necessarily just naturally occurring in nature, because some of these are actually man-made, especially when you get down in here. So if you see like the names of some of these, like for example, like if you look at this one, number 63, this one's like europium, sounds like Europe, okay? And then you have the one under that is americium, which sounds like America. You got neptunium. You got one called einsteinium, number 99 is called einsteinium, okay? It is right here, okay? So some of these are actually man-made, okay? But these are the elements, okay? So, and you've heard of a lot of these: hydrogen, sodium, lithium, oxygen, carbon, aluminum, zinc, cobalt, nickel, silver, gold, platinum, lead, tin, aluminum. It's the stuff, it's like some of them are metals, some of them aren't. But the whole thing is that you absolutely have to know is that once you get down to an element, you cannot break it down into anything else. That's what it is, okay? An element cannot be chemically or physically broken down at all. So if you want to make a note that cannot be physically, I'm just going to say physically or chemically broken down, okay? You're going to have to know that. All right. Now, on the other hand, also on this side, you have compounds, okay? Compounds are two or more elements put together, okay? Combined chemically, two or more elements, we're gonna say combined chemically, because I can't just put, you know, some copper and some zinc next to each other and think that I have a compound. It's just copper and zinc. They have to be combined chemically. All right, and usually when we talk about something being combined chemically, there's like some type of force of nature or something with electricity or something with fire, okay? So a compound again is two or more, so at least two elements combined chemically. So they get put together chemically, okay? We know a lot of examples of compounds. We just don't know that we know a lot of examples. For example, does anybody know the chemical, what about the chemical formula for water? What about water? What's the formula? So what elements is it made up of?
2 hydrogen atoms and 1 oxygen.
Very nice. Excellent. So for example, all right, water is H2O. Okay, that's what water is. All right. And so you have, like somebody said, you have 2 hydrogen atoms and then you have 1 oxygen atom. Okay, 2 hydrogen atoms, 1 oxygen atom. I'm going to give you another example. Actually, I'm going to give you 2 more examples. And I would say you probably use these every day. Okay, one of them is this. Anybody know what that is? You will find it in your kitchen. And it's called, the name of it is sodium. This is sodium. And this is chlorine, but we say sodium chloride. Anybody know what sodium chloride is?
What is it, Clorox?
Nope. That's a good guess though. This is actually table salt. Okay. And I call it table salt because we have a lot of different salts, but it's just the salt that you put on your food. Okay. Now, when you have a compound, okay, which is the 2 or more elements put together, let's look at these 2 that we have. Okay. H2O and NaCl. Those are very different. The properties for that, chemically and physically, are very, very different than those individual elements, okay? So for example, when I'm looking at H2O, this one, hydrogen, is a gas, okay? Oxygen is a gas that we need to live, okay? But when I chemically combine them, it's a liquid that we also need to live, okay? It's a liquid, okay? So the properties are totally different. It looks different. The chemical properties, like whether it's flammable or, you know, all that other chemical properties, those are totally different. Same thing for table salt. Sodium, I have a cool video for you guys. I'll show it to you one day. Sodium, believe it or not, is actually a metal, okay? And it's a highly reactive metal. So that's a chemical property. It is highly reactive. So much so that if I buy sodium, they send it and it's like submerged in oil. So it's like sunk down in some oil, because sodium, when it comes into contact with like moisture and even in the air, not just like me throwing it in some water, but even in the air, it will ignite and catch on fire, okay? Chlorine, you're probably used to hearing about it being in your pool, but it's really a gas. It's a yellow gas, okay? So you got a metal, sodium's a metal, and you have chlorine, which is a gas. But when I chemically combine them, we get the stuff that we put on our food, okay? I'll give you one more example. I'm just gonna see if anybody can guess this one. This is C12H22O, I think it's 11, I think. Yes, C12H22O11. I bet this is some of you guys' favorite. You just don't even know it. It is also in your kitchen. What'd you say?
That's like chloride, hydrogen, oxygen, something.
Yeah, so the fancy name for this, so it would be, there's a super long fancy name that I honestly cannot remember right now.
Photosynthesis, something like that.
It's glucose,
Oh.
glucose, which is also known as, any guesses? It's in your kitchen.
Sugar.
Yep, it's sugar. Very nice. And again, look, this is, oxygen is normally a gas, hydrogen normal gas, carbon is what our body's made of, okay? So again, thank goodness we're not putting gases and body parts on our cereal when we get ready to eat it. It's just sugar, okay? So that's what a compound is. So we have elements and we have compounds. Now, elements cannot, oops, I didn't mean to erase there. Elements cannot be physically nor chemically broken down, okay? Compounds can't be physically broken down, but they can be chemically broken down, okay? So I can take any of these and I can do something to break them down chemically. It's just gonna take a lot of energy. A lot of times it takes a lot of heat too. Like for instance, H2O, I can actually do something called electrolysis, okay, which kind of sounds like electricity, so it kind of has something to do with that, and run it through and it will break it back out into its gases, okay? So it's just difficult to do, but we can break those down. So that is on one side of the matter concept map. Then if we go to this other side, does anybody know how we said, how do we differentiate between these three different types of mixtures? How do we differentiate between them? What's the difference between them?
The amount of electrons and what are the things called?
Protons.
Yeah, that in
So that is
element.
important, but that's usually more when we talk about atoms. So there's really just, I'm just looking for one trait that's like, well, the reason why this is the solution is because of this. But if it changed a little bit, it could be a colloid. If it changed a little bit more, it could be suspension. So it should be in your notes. Everybody check your notes. What makes this different? I'll tell you, I'll give you a hint. I probably drew an arrow and said something like it went this way.
The size.
Yes, very nice. The size of the particles, okay? So the difference between these, the only difference really is particle size. So these are the smallest, okay? And these are the biggest, all right? And everything else is in between. So this has to do with, I'll write it right here. This is particle, I'm just gonna say part size, particle size. Now, remember, all of these are types of mixtures, okay? So let's do, there are types of mixtures, all right? And we had two types of mixtures, did we not? Some of the mixtures look the same throughout and some mixtures look different. Anybody remember what those words were? They both started with H. One type of mixture.
Homogeneous, heterogeneous.
Very nice. One type of mixture looks the same and one looks different. Which one means the same?
Homogeneous.
Very nice. Homogeneous. Those are the ones that look the same, okay? And hetero, which means different, okay? All right, homogeneous and heterogeneous. So when we talked about these in our notes, we said that these two guys fell under the heterogeneous ones. And then homogeneous mixtures, really, you don't even have to say, you could say homogeneous mixture, or I could just straight up call it a solution because that's what it is. So a solution is a homogeneous mixture, okay? And if you think about it, okay, if you think about it for a second, that should make sense. If a solution has really, really, really small particles, they're the smallest particles. If I mix them in with something, they're so tiny, I can't see them. That's why it looks the same, okay? So that's why it looks the same. So for example, let's say I wanted to make lemonade. Okay, I wanted to make lemonade, and I'm not that great at making lemonade. So I'm gonna use like country time or like, the powder mix. Okay, so I'm gonna take, a pitcher of water, right? So I'm gonna try to draw pictures just because. All right, so if I take a pitcher of water or a glass of water, and then I put my lemonade mix in there, okay? I put it in there and I stir it up. Eventually, you're not going to see it anymore. It's just going to look like yellow water. It's going to be clear inside, okay? Or yellow, okay? So that is so the particles or the powder I put in there is so tiny that when I make my lemonade mix, you can't see it. That's a solution, okay? Now, if I go to the other end of the spectrum, let's say Camille makes lemonade and she's way better at making lemonade than me. She can make it from scratch. She's gonna use some lemons. She's gonna use some sugar. She's gonna have her water. She's gonna mix it. Why would her lemonade not be a solution? Why does it not look the same throughout? Any guesses? Think about what she used to make it. What would you see in her lemonade that you didn't see in mine?
Lemons.
Yeah, you can see the stuff from the lemons, right? If you squeeze a lemon, what could you possibly have in your lemonade? Couldn't you have
Seeds.
seeds? Yes, you could have seeds. What else could you have in there? The
From the actual
The,
lemon.
yeah, the lemons little things. I can't.
yeah, like the pulp or whatever, right? So her lemonade looks different than mine. I can see the different pieces. Hers is not a solution, okay? In fact, it's going to be a suspension. Now, suspensions have the biggest particles. You can see them, okay? And a lot of times, those particles are so big, and when I say big, that's relative, right? It doesn't mean like big as a classroom. It just means you can see it, okay? Sometimes those particles are so big, they tend to sink to the bottom. If Camille just left her lemonade on the counter, I would assume, and if I walk by, I could see some pulp floating in it, but the seeds might go to the bottom, okay? We actually drink suspensions all the time. You see them all the time in the store, okay? Like for instance, if you buy, if you do a protein drink or like a protein shake or like a naked juice or a smoothie, or maybe even some fresh squeezed orange juice, if you buy from the store, what does it usually say you need to do before you open it and drink it?
Shake it.
Shake it.
Very nice. It says shake well. It always says shake well, before you consume it. Why? Because all this stuff is at the bottom. If you go to the grocery store anytime soon and you go find a container of orange juice, like back in the freezer section, if you look, it's going to be like juice, juice, juice. And then there's going to be like this big, thick, dark layer down here. Okay. And it's going to say on the side of the container, it's going to say shake well before use, because all that stuff has now settled to the bottom. Okay. So suspensions, big particles, they settle to the bottom. We need to shake them if it's something we're going to drink, or even if it's not something we're going to drink, you still need to shake it so it can mix back up. Okay. Now, a colloid is in the middle. Okay. So they have like medium-sized particles. Sometimes you can see them, sometimes you can't. Sometimes you can't see them just because of what color they are. So for instance, a lot of colloids that I tend to think about are like white. Okay, so for instance, like milk or toothpaste or shaving cream. Okay, so a lot of these are colloids. They have particles, but they're not super tiny, but they're not like big. Like I don't have to shake my toothpaste before I make it. Now, here's the cool thing about milk, or I guess it's cool. Maybe it's not cool, okay? If you ever look at milk in the store, sometimes it says that it has been, whoops, hold on. Ugh. My sweater touched the screen. It says it has been homogenized. Didn't we just say a word that sounded something like this? What did we say earlier that sounded like this? Can we have another word that sounded something like that? Yes, no, maybe so.
Homogeneous.
Homogeneous, okay? And remember, this meant the same. So if milk has been homogenized, they have prepared it so that it looks the same throughout. That's basically what happened, okay? Milk actually has different parts. There's a lot of fat in milk. That's why when you go to the store, they say, do you want whole milk, i.e. all the fat in there, or do you want 2%, a little bit of fat in there, or do you want 1% or skim milk? There's not a lot of fat in there at all, okay? But realistically, if I did not homogenize or shake and stir and get that milk to look like a solution, that fat would be like floating on the top. Doesn't that just sound delicious, okay? So we usually have our milk is homogenized so we can drink it until it can no longer be homogenized, and then it has gone bad. And that's when you have all the chunks floating in it. It is no longer homogenized. It has curdled and it's disgusting. Okay, so those are the different types of mixtures. And specifically, remember, the reason what makes them different is the particle size. So it goes from smallest up to biggest. Solution's the smallest. That's why it looks the same throughout. And then colloids are next, and then suspensions have the biggest particles. And that's why they say shake well, because all the stuff floats to the bottom, or not floats to the bottom, but sinks to the bottom. Okay. All right. So I have one more vocab word I want to give you. Okay. And it is a special type of solution. I didn't talk about this in the notes. So this is a special type of solution. I'm just going to do it right. Let's do it right here. Okay. A special solution. I'm going to shorthand it. That's solution. Okay. And it's made up of two metals. Two metals mixed together. And we call it an alloy. A-L-L-O-Y. Okay. Alloy. It is a special type of solution where they have mixed two metals together. Okay, they've mixed two metals together. So I'm going to switch back to my periodic table. Okay, and I want you to see if you can guess. Let's see. All right, so here is my periodic table again, okay? I want you to note that, let's see if I can, or I can't do it. All right, so these, I want you to look at, there's a lot of different metals on here, all right? So I'm gonna kind of name some of the more common ones. So you got iron, cobalt, nickel, copper, zinc, here's aluminum, tin, lead, mercury, gold, platinum, silver. What else do we got? That's really common. Those are really common ones, okay? All right, so now I want you to think about this. There are three metals in particular that I'm thinking about, okay? Three metals in particular that I'm thinking about that are alloys. That means they are not on the periodic table because they're not an element. It's a compound or a solution of metals, okay? All right, so looking at this for a second, so I named off most of the common metals. I'm thinking of three metals, okay? One of the metals, let's see, two of them both start with Br, okay, Br, and and then one is my favorite football team because that's who I'm a fan of. So their name kind of sounds like one of the metals. Any guesses on what they are? One of the metals is, did somebody put it in the chat already? Oh, okay.
Are you a Steelers fan?
I am a Steelers fan. Yes, you're the first person to get that. Everybody's like, what? Somebody yesterday was like, the Browns. I was like, Brown is not a metal. Yes, Steel is one of them. Steel is one of the alloys. So alloy, can you guys see this color? Or do I need to change the color?
I can see it.
I can see it.
Okay, alloy examples. One is steel. The next two start with a BR. One of them you may be familiar with if you are in band. The other one you may be
Brass?
Yes, very nice. Brass. Brass is actually a combination of copper and zinc. Okay. And then another one you may be familiar with if you've ever gone to an awards program or participated in some type of competition.
Bronze.
Bronze, very nice. Okay. So all of these are not on the periodic table, but they are special solutions. Okay. And the reason why we mix metals is because it gives us different properties. Now, let me give you a little bit of love advice before we close out today. Okay. So gold is an element. However, the gold that we wear in our jewelry is actually an alloy. So it is a mixture of gold and another metal. So let's just say you decide you are going to give your significant other a nice gift, okay? And they are kind of a little bit high class, a little on the bougie side, and they're like, please make sure you give me, what's the highest gold you can think of? How do we do the gold? What was Bruno Mars' song?
24
White
karat.
gold.
24 karat gold. There we go. All right. So your significant other says, it better be 24 karat because if you love me, you'll buy me 24 karat gold. And you're like, I ain't got 24 karat money. I'm going to need you either 14 or 10. Okay. And let's say they get mad. Here's what you tell them. You know, I could buy you the 24 karat gold, which has more gold. Okay. So the gold amount of gold in these goes down as you go down in carats. However, 24 karat gold is actually kind of soft. So if you get them 24 karat gold and they pull at their necklace or they hit their ring on a table or their bracelet, it might break or bend or mess up some kind of way. So you can say, look, babe, I got you this 10 karat because I want it to last forever, just like our love. And you can save yourself some money. You're welcome. I just saved your whole relationship in your pocket, okay? So you buy them the cheap gold, don't buy them 24, 14 karat gold. Buy them the cheap gold, save yourself some money, and do a shameless plug, okay? All right, real quick, here's what you need to know. You need to know these vocab words: element, compound, solution, colloid, suspension, homogeneous, heterogeneous. This is a very vocab heavy one, okay? Alloy, all right? And you also need to know, especially when it comes to these, this one, homogeneous, heterogeneous, elements and compounds, you need to know which ones can be broken down physically, which ones can be broken down chemically, which ones can't be broken down at all. So how or if you can break down physically or chemically, okay? Because mixtures, you can break those down physically, okay? They can be broken down physically, all right? Any questions? All right, listen to me carefully, okay? Let me do a new share. All right. Let me just show you guys what it looks like, okay? When you do your ed puzzle, this is what it looks like to me, okay? I can see if you've done your ed puzzle or if you started and you did not finish it, okay? So if you are up here and you did not do your ed puzzle, you're gonna stay on and you're about to do your ed puzzle, okay? Also, you're supposed to submit your notes. So I did have like at least one person who submitted their notes, but they did not submit their ed puzzle. So when you do the ed puzzle and you write down everything, You're submitting here. If you're on here, you have to watch the video. When you get ready to watch the video, you have to click this Chem 1B and watch the video on Edpuzzle. That's the only way it shows up over here that you did it. Okay, so I'm trying to give you
Okay. Can you go to your Chem 1A class? I clicked on that one.
Okay, I'll go look in there. Okay. All right.
All
So
right, because I have the thing that I did. I have the score that I did do it. A
okay.
screenshot of it, just in case.
Okay. So if listen to me carefully, do not leave if I do not call your